大家好，前两天华为在国际电路与系统大会上发布了涛等比定律。这两天晚上的舆论直接吵翻了天，很多人骂说华为又在吹牛皮，玩文字游戏，甚至有人冷嘲热讽说这不过又是一个为了弯道超车而搞出来的营销炒作。更有意思的是，连英伟达的黄仁勋前两天在台北访问时直言，这东西台积电10年前就在做了，技术早就有积累了。
And Huawei using that technology allows them to double, triple, quadruple the amount of transistors without making the semiconductor geometry more fine. And so it's a very good technology, but TSMC and Taiwan have that technology.
既然这不是什么新的技术，很多人觉得它是炒作，那为什么路透社、彭博社甚至华尔街的分析师会对这件事情表现得前所未有的郑重和紧张呢？他们到底在怕什么？要看懂这场博弈，我们得先把吹牛和事实分开。黄仁勋说的没错，台积电、英特尔确实早就开始玩 3D 堆叠和先进封装了，但台积电的逻辑是，我有最先进的 EUV 光刻机，做出世界上最小的2纳米平面芯片，同时我能再用 3D 封装把它叠起来，这就是锦上添花。很多人觉得看吧，连科技巨头都发话了，华为不过是在炒作台积电玩剩下的概念。但是事实真的是如此吗？黄仁勋说台积电10年前在做 3D 堆叠，这是大实话，但很多人没搞懂，台积电的堆叠和华为的涛定律根本是2条完全不同的技术路线。台积电玩的是物理空间的折叠，它拥有世界上最先进的光刻机，把晶体管做得极小，在平面上塞不下了，它就通过高精密的物理工艺，把2颗芯片像盖摩天大楼一样一层层往上叠。台积电拼的是材料、物理精度和顶级设备，而华为的涛定律拼的是算法、软件和电路拓扑的重构，它叫逻辑折叠。什么意思呢？华为发现西方的芯片虽然晶体管更小，但数据在芯片内部走的是传统马路，经常堵车。在无法获得最先进的光刻机的情况下，直接用数学和算法在芯片内部的逻辑门之间架设了一套全自动的多维立交桥。它缩短的不是晶体管物理距离，而是数据传输时间的常数涛。台积电走的是物理路线，拼的是剑法。华为走的是系统和算法路线，拼的是内功。最硬核的地方在哪儿呢？这绝不是一张 PPT。华为海思在现场直接丢出了底牌。过去的6年，在全面被卡脖子的情况下，华为用这套方法论已经量产了381颗芯片。西方在过去50年靠顶级设备把尺寸做得更小，而华为现在用量产数据证明的是，即便没有最先进的光刻机，靠算法、靠架构也能让信息跑得一样快。接下来我们看一下这一段 CNBC 的专家分析，看华尔街是怎么看待这个破局者的。
Are we really just shifting away from Moore's law in this industry in China at least? I wonder what you're thinking about in the big picture. Are we going to sort of end up seeing some kind of bipolar world? China has come up with new ways of doing things, and if they keep going in this direction, we might have that, actually.
I think bringing up Moore's law is very important here. I think probably the naming of this Tau scaling law was very intentional in a certain extent, because you could argue for the last, 50 years, it was always about Moore's law, and it's a well-trodden trope that Moore's law is dead. You know, this Tau scaling law, I think why it became so important is really showing that it is dead in a sense. It is about everything else to a certain extent, beyond just the transistor size. Most of the semiconductor manufacturing players have already started following this path to one form or another. I mean, TSMC is very good at advanced packaging, very good at looking at different ways to add power to the chip. And remember, a lot of these chip names nowadays aren't actually what they mean. When you say like a 2 nanometer node these days, it's not actually 2 nanometers. There's actually a lot that's equivalent to 2 nanometers is why they're doing it. So I think what Huawei is saying today is that we will have our own way of doing things. It may be similar, may be different. We'll see when it actually comes out, but it will be different. But I think to your point about the bipolar world, that's very clear. They're putting a line in the sand, and look, there's a path we're going to follow. There's probably a lot of companies in China that will follow us on this path, and that looks like where we're headed to right now.
Do you think that like now corporate China is unwilling to bring in Nvidia's chips? They don't really need that anymore?
Longer term, I think that's likely to be the plan, to try to localize as much of the chips as possible. And to also remember, it's a dance, right? You need to have the software stack and the hardware stack to work together. This is what China is trying to optimize for right now.
Yeah, how commercially viable is this new design technology that Huawei just talked about? I mean, sounds like there might be, cooling system, expensive ones that are needed. And can Huawei mass produce these, pretty cheaply?
I would say on the face of it, it doesn't seem extremely likely they'll be nearly, in terms of yields or performance, as high as what's available today. Base case, I would say, for most people at this point. But that said, remember, the Chinese semiconductor industry in China is not just about commercials application, in the sense that it's not necessarily about everyone needs to make the highest margins, the highest yields, pay the highest returns. And this is a very heavily subsidized industry. There's a lot of investment by the government, which makes me think the result is what matters, not necessarily the yield or a lot of other things. As long as they get the result, I think a lot of those things will come with time.
And what does this mean for the trillions of dollars invested into Western chip stocks and their infrastructure? I mean, are they going to lose their edge with, these new chip designs by Chinese chip makers?
I think a really good corollary here is probably the AI thing, right? And everyone's sort of following the same path. I think this could be a similar sort of situation where Huawei is going to go out, think of a lot of ways to, as I mentioned, but that's not to say TSMC, Samsung, etc. will not follow something similar. I think they could do something like that as well. But it really just comes down to, do they need to, right? And I think that's the big difference, because if you already have these amazing tools in place, right, and you've already built all this big supply chain, you don't necessarily need to do it right now. That's not saying that they're not thinking about it, right? So even though at the moment it may not be following the same path, I can see these paths converging over time. You could argue that, again, without EUV, without a lot of these tools, maybe Huawei is still a bit handicapped.
看完这段采访，大家应该能感受到一种微妙的气氛。西方媒体真正担忧的根本不是华为有没有发明出一套新理论，而是华为被彻底制裁，没有最先进的光刻机的情况下，竟然硬生生的绕过了封锁，就可以把中国的高端芯片锁死在过去。但是华为呢，在封锁的荒地上展出了一套不依靠西方的第二曲线。荒地堆叠在手机上确实受限于功耗、散热等，像带着镣铐在跳舞。但 AI 集群、数据中心、智能汽车这些领域，散热可以靠水冷，体积可以放大。只要能把等效性能推上去，中国的 AI 算力供应链就彻底闭环。更让西方不安的是，从底层的涛定律架构，针对中国芯片优化出更多的软件生态，再到 AI 大模型，中国正在展出一套属于自己的科技树。美国的技术封锁反而逼着我们从根上重建另一套科技系统。接下来，这位美国技术博主的观点更是一针见血。
is one of the big concerns that I have is that when we refuse to allow China to use the legacy architecture that's been built up over the past 5 decades, one of the problems that we might run into is they actually start building crap based off of 2020 architecture versus 1970s architecture. And I've talked about how, once you go legacy, you just do not go back. The metaphor that I use, the story that I use a lot for this is basically TCP/IP version 4. So this is the networking protocol that in 2026 is still the primary protocol that we're using. And now it's 2026. And by golly, you're still using IPv4. Why? Because once you go legacy, you just don't go back. And so there are so many things in the technology world where there would be better ways to build systems. There would be better ways to architect systems if we started from square one and basically built based off of what we understand now. But we have all of this luggage, all of this baggage for everything that we've created before. And so we just have to basically keep building on top of that. One of the concerns that I've had with this whole forcing China to break from our legacy architecture is what happens if they start designing for the 2020s world? What if their square one, what if their base, their foundation for the technology starts in the 2020s? So coming from CNBC, Huawei plans new smartphone chips this fall as rivalry with Nvidia and Apple heats up. What it looks like what Huawei is doing now is, since they can't get their hands on the American processors, the Western processors, they're going back to the drawing board to redesign how processors should be created. And it looks like they have some good ideas. One of the things I think about this is back in the Pentium 4 era. So Intel, back when Intel was Intel. Anyways, back during the P4 era, we thought we'd have 10 gigahertz processors by now. The problem that they ran into is once you get above 3 gigahertz, you just start creating so much heat. Basically, you're creating more heat than anything else, and it becomes a wee bit of a disaster. And so it was after that era, that is where we started getting the multi-cores in the single processors, where you started hearing about dual core, quad core. Now you might have like 30. So it was better. Instead of having one processor run at 5 gigahertz, you could have 6 processors, 6 cores running at 1 gigahertz each. And the idea was that actually gives you better performance and better output. And that's the thing to be thinking about when we start talking about architecting processors. There are different ways to create these processors, and you create the processors based off of the problems that you run into at the time, right? Huawei said that by 2031, its new chip technology could deliver capabilities equivalent to the 1.4 nanometer process technology, while global chip leader TSMC has begun volume production of 2 nanometer chips. This is the other thing to be thinking about. Is that basically capabilities equivalent to the 1.4 nanometer process technology. And so what's interesting here is basically Huawei is coming out, and what they're saying is that they'll get the capabilities equivalent of a 1.4 nanometer process. But it's not a, quote, true 4 nanometer process. But again, at the end of the day, if it walks like a duck, it quacks like a duck, and you call it a bear, doesn't matter. Huawei said it developed a new engineering approach called logic folding to manufacture its Kirin smartphone chips this fall. The new principle, quote, is more a systems level optimization doctrine, shorten wires, stack logic, improve memory semantics, and co-design chips, packages, software, and clusters. One of the important things to understand is that they're not necessarily building the best chips or the best hardware they theoretically could, right? But here's the thing. You go to the boss after you've already spent billions of dollars and you say, okay, boss, here is the product, here is the process, here is everything. And it cost us $10 billion to get here. But it's not the best way to do it. If you only give me $5 billion more and another couple of years, I can give you a much better way of doing things. And the boss is going to look at you, so we can start manufacturing this crap next month and start making revenue and profit off of it next month. Or you want $5 billion more to basically give me the exact same output, the exact same solution, but, engineered in a better way. And I have to wait years for that. No, ship it. Ship it. Ship it now. Well, the curious thing is, right, you have China, right? China is not being allowed to use any of this legacy architecture. They're not being allowed to build off of everything that has been created over the past 30 years. So they have to go back to the drawing board. And so the question is if you had to build the technology stack today, would you start from where we started from back in the 1970s or whatever else? And the answer is no. Obviously not. And my big concern is the fundamental problem the Western world is going to have is simply that the foundations of our stack are going to be 50 years old, or the foundations of their stack are going to be 5 years old. And that does not bode well over the long term.
这位美国博主的一句话特别狠，西方的科技最大的优势，同时也是最大的历史包袱。过去的50年积累下来的 X86 架构软件生态已经太庞大了，就像是一栋建立在1970年代地基上的超级摩天大楼，越庞大就越难翻身。而中国被全面封锁以后，反而出现了一套戏剧性的结果。我们没有历史包袱，很多底层架构可以直接按照2020年代的 AI 逻辑和异构路线从零重构。但这条路能不能彻底成功，现在没人敢下结论。但有一点可以确定，全球科技真的开始分叉了。看完这些交锋，我最大的感受是，这场竞争早就已经超越了谁的芯片更先进这种低维度的讨论。全世界只有一套科技体系，所有人必须接入美国主导的世界。但今天 中国科技硬是自己铺出了一条路。西方依然掌握着全球最强的工业生态，中国新路线也注定了充满荆棘和困难。我们不必盲目自大，也绝对不要妄自菲薄。这些东西一旦完成了从被动跟随到主动探索的惊天一跃，结局就彻底不一样了。也许5年后回头看，涛定律可能只是一次充满争议的尝试，但也有可能人类的科技正在向双极世界的起点就是从这一刻开始的。你把最理性和最真实的想法留在评论区，5年后回来看一下今天谁的预判才是对的。技术高墙挡不住长夜，属于中国技术大航海时代的新变局才刚刚拉开序幕。谢谢大家，下期再见。